Problem number 6, the accompanying table provides data for the tar, nicotine, and carbon monoxide, which is CO, and that contains in a certain brand of cigarette. Okay, find the best regression equation for predicting the amount of nicotine in a cigarette. Why is it the best? Okay, first let's go and get our regression line, and then we'll move further. So, moving to StatCrunch. Stat. So we are choosing this time multiple regression because multiple linear because we have several variables, right? We have several x's. Yes, in this case we have 2 x's. Therefore, we are going to choose, since our variable, our response or dependent variable is nicotine, and x is going to be CO and tar. Why is it not allow me to add 1? Let me see which one I have. See, it's giving me trouble. Let me put CO right now, and then I'll check. Okay, this is CO, and then I need one more. Did I not choose multiple one? Stat, simple, multiple, okay. Multiple linear, okay. Then we are choosing nicotine as a Y. And then X variables. Asking for 2, it's gonna be tar. Okay, and both of them, very good. I was able to choose it, both of them. Okay. And clicking compute. There we have. So what do we have here? Is going to be our, let's see, intercept 0.8183. This is as a parameter and estimate. Let me see. We are going to have how many? 3, right? Tar and CO, okay. So it's going to be this one, looks like. 0.1837. So 0.1837, okay. Or maybe I think it was three of them, so then I'll round it up. 1 second, 3 will become 4. Okay. Next tar is going to be 0.092. 0.092. Oops. It came out as a comma. Okay. And CO is negative 0.033. Okay. Negative 0.033. Okay, excellent job. So moving to next one, question. So which equation is the best? It is the best equation of the 3 because it has highest adjusted R squared. Okay, let's go to see our R squared. Actually, here it is equation also given. So R squared is 0.9311 and R squared 0.9249. Close. They are close to each other. So is the best of the three because it has the highest adjusted R square, the lowest p-value obviously, and removing either predictor noticeably decreases the quality of the model. So A, because once you remove any of this variable, it's gonna decrease the quality because it will increase adjusted R squared and R squared, so error will increase. Did I choose something wrong? It's the best quality equation of the three because it has the highest R squared, the lowest p-value, and here it is removing. Okay. Here it also was removing. Either predictor noticeably decreases the quality. I think it's the same sentence, no? Same conclusion. It is the best equation of the three. I'm checking A and D because it has the lowest here it says. Okay, yeah, the highest adjusted R squared. Okay, this time it should be fine. Okay, question number 7. So what do we have? Number 6. This is continuation. All right, so there are endless questions. Okay, so what is going to be the last question? Is the best regression equation a good regression equation for predicting the nicotine content? Why and why not? First of all, the most important thing is the p-value when it's very small, then that indicates that the model is a good fitting model. Where is it? Yes, so it's going to be either B or B or D. So p-value indicate that the model is good fitting, and prediction using the regression equation are close to accurate. Close to accurate. So which one is it of this one? D. Okay. Did I mess up something again? Large p-value, duh. Sorry. The small p-value indicates I'm saying small and choosing large. Small p-value indicates that the model is good fitting model, and prediction using the regression equation are likely to be accurate. It should be it. Hold on. Okay. Finally, moving to question number 7. What do we have here? Refer to the data table below, complete A through B. Okay. Pay attention that here it says use predictor variable of brain volume and or weight. Why it says and or? So we're going to take in one case both of them, in the other case we're taking only one of them to find the best fit of regression equation. Okay, all right, so let's go. That and regression, choosing multiple because we're going to choose both of them. IQ, and let's choose both of them. Okay, and compute. Okay, this is what we have. Intercept, coefficient of brain volume, and body weight. How are we going to figure out if this is a good fit? We are going to look at our R squared versus R squared adjusted. Look what a big difference, 0.0011 and then negative 0.1164. It's kind of a big difference between them. So I would try to see the second one, see whichever has less difference between adjusted and R squared. That one would be the best fit, obviously. So let's change it. So instead of option, I'm clicking edit. And I'm choosing only one this time. Okay, let me choose the volume and compute. Okay, so we have intercept and brain volume. As you can see, I didn't go and chose the linear regression instead of multiple because it doesn't matter. Automatically, if I put 1x, it just automatically will give us, instead of multiple, just linear regression. And let's see, 0.0011 instead of negative 0.11, we have negative 0.05. So this is better fit, right? So therefore, I'm going to use this one. So 104 point, so it doesn't mean that yours also going to be the same. You just look at compare both cases and see which one has more the narrow, the error. And that one would be your best fit. So going back to intercept, fill out the intercept. So 104 and 4 digits, okay, 8351. 104, where is it? Point 8351. This is first one. Moving to coefficient of volume, negative 0.0035. Okay. What is incorrect? 1, 2, 3, 4. Let me check. 0.2034. 340, 350, 00350. Jesus Christ. Yeah, I did. I put 0035. Now 10.8351. Let's check this one. 104.8351. Okay. Don't mind me. I'm tired. I have enough of these recordings. Okay, we have it. So, why it is the best? Again, because it has the highest adjusted R squared, which means it's a closer to R squared, right? Then less mistake, and the lowest p-value. These two conditions are making the best fit, and even less number of predictor. Let me choose this one. The words are so same, it's easy to confuse which one okay, this is greatest number, no. Highest and lowest, the greatest number, no. Fewest number, the best of 3 because it has, no, the lowest, okay, C. All right. And based on this result, can researcher predict some IQ score if he or she knows the volume and weight of their brain? No. it can't. Because adjusted R squared value is low. So it's going to be either B or D. Low meaning it's negative, right? So usually our the predictions use the regression equation that are unlikely to be accurate. So it's going to be this one. No, high, because adjusted value is low. Don't come to look at here at the answer B when we said the highest adjusted R squared. That's mean the highest meaning it's close to the prediction, close to the R squared, but by absolute value when you are taking itself, it's low, it's negative. So prediction using the regression equation are unlikely to be accurate. Bingo. Oh God, we have D also. Based on the result, does it appear that people with larger brains have higher IQ score? Definitely not, because the regression equation, it doesn't have significance, so we can figure it out if it's significant or not. So no, because regression does not have overall significance. There we go, here it is. Moving to question number 8. Okay, what do we have here? We are going to test the claim B1 is equal 0. All right. So if the coefficient B1 has a non-zero value, then it is helpful in predicting the value of the response variable. If B1 is 0, it is not helpful in predicting the value of the response variable and can be eliminated from the regression equation. To test the claim, B1 is equal 0. Okay, so it's going to be this one, B1 is equal 0. What is B1? Those are, we call multiple regression equation coefficients for population data. Lowercase b, those are for sample data, right? Next, let's see the test statistics. Since it's talking about Hive, test statistics, 11 point, we have 3 digits, 11.113. So it's going to be 11.113. Okay, p-value, I noticed it was all zeros. So we reject null hypothesis because p-value is very small and conclude that the regression coefficient B1, that is our estimate value, which is going to be for Hive estimate, it's the first column, 0.785. Let me write down 0.785. And because we reject null hypothesis, that means we fail to reject alternative, which means we support in the language of regression, we keep it, will be kept. Okay, second one, question, let me see. What is about the second equation? So now we test the claim that B2 is equal 0, okay? Is equal 0. So test statistics is going to be for the waist, because B2 is going to be our waist. It's given 32.127. 32.127. P-value same way is all 0. Since p-value is 0, then we reject null hypothesis, and B2, let me see, what is B2? Okay, B2 is the estimate value, which is in the first column, 1.090, right? Because if I round this 9, it's going to be 0 and 8 become 9 automatically. 1.090. 1.090. Okay, and it should be kept. Obviously, if we reject null hypothesis, then we fail to reject alternative one. Okay? So, and the last one, well, I hope it's the last one. I thought it says from when? From A to D or A to C? Okay, we'll see. We'll see. So, what do the result imply about regression equation? Well, because we support or we keep both, in both cases, our alternative hypothesis. Therefore, they both would be included, both cases, okay? Both independent variables. So, and waist and height. So, the results imply that equation regression should only include, result imply that the equation should not include, should include both. Here it is, D. Why we include both? Because we accept alternative one, right? We support, which is we say we should keep it. All right. Moving to question number 9. So an equation expresses a linear relationship between response variable y and two or more predictor variables. I put such simple questions so you would know these understandings of what is called what also. So if we have one dependent variable and several independent, that one we call multiple regression. Question number 10. So where the D is multiple coefficient of determinant R squared modified to account for the number of variables and sample size. Okay, that's easy. Adjusted coefficient of determination. And number 11. What do we have? Which of the following is not guideline for finding the best multiple regression equation? Okay. Consider equation with high values of adjusted R squared and try to include only a few variables. It is a guideline, right? Because we are choosing the high value of adjusted R squared. Next, consider the p-value to select an equation having overall significance. Yes, it is a guideline. Use common sense and practical consideration to include or exclude variable. Well, include or exclude it based on comparing R square adjusted to R, right? And if two predictors value have a very high linear correlation coefficient, both should be included finding the multiple regression equation. No, that doesn't mean they both would be included. Let's have a very high linear correlation coefficient because we are not looking about correlation between themselves, right? We are looking for correlation coefficient between x and y. Okay, so this is the one that is not guideline. Okay, and moving to question number 12. No, that's it. We're done. All right. This problem is done.